Begin with, I'm going to show you an example of Lab 4 actually running. And what we're trying to do is to measure the temperature of a heating system, and our heating system happens to be just a small light bulb. And what you will notice here is that there are 4 colored lines. And these colored lines represent, well, this one on top here, the upper threshold in red, the lower threshold in blue, and this green line is an indication of when the lamp is actually on or off. So up here it's on, down here it's off. And you should notice that as soon as the temperature goes below the lower threshold, lamp comes on. When it goes above the upper threshold, lamp goes off. Same thing here, it's just repeating over and over again. And it's taking about 50 milliseconds per sample, and there's around 1,000 samples on the screen. What the screen is showing you is the measured supply voltage, thermistor voltage, the resistance, the filtered temperature. These are user inputs. These are the set points and the deadband. And you can calculate the high and low temperature by taking the set point and subtracting half of the deadband. So that would be 27.5, and then set point plus half of the deadband, that's 28.5. Okay, so that shows you pretty much all of the front panel. And there's also an indicator that the heat will come on, and this light will also turn on. All right, now we're looking at the block diagram, and actually I've minimized the formula node so that not all the answers to what you need to do are displayed here. But I've added some probes, and you can see I have the thermistor voltage probe. And to get a probe up on the screen, like for example, let's say I wanted to add a probe here, you just hover over the wire, it changes to the letter P, and then you click on probe, and now it has a probe indicating that that's true. Okay, so I have a few probes here. I have one for the thermistor voltage, which I put here, number 1, supply voltage number 2, resistance number 3, filtered temperature number 4, and heat on or off is another probe. So all these probes are telling me my current values. For example, the supply voltage is 4.3, the thermistor voltage 2.3, and the resistance, and then the temperature. And obviously all of these are changing. When you see a number like this, like 8.8 something to the positive 3, that would be like kiloohms if you wanted to change it to SI units. Okay, so let's see what some of these things are doing. I'm going to minimize this and stop this. Let's open the linear interpolation, which converts resistance to temperature. So I'm going to open this up, and we want to look at the table. So this table is showing us a resistance value and how it's converted to temperature. For example, if the thermistor is 10K, it'll give us a temperature of 25. If it's 8K, 30. And it uses linear interpolation to find any temperature given any resistor value. And it does it very, very quickly. Now, after closing this box, we'll open up the filtered signal. And the filter type is called a smoothing filter. And there are some specifications. It's a moving average, rectangular type, and the half width of that moving average is 10. What the half width will do is measure or sample 21 times in total. 10 before the current sample, 10 after, and the current sample. That's where you get the sum of 21. Okay. Now the other thing to look at are the inputs and the outputs. So if I'm stopped right now, so I can open up this box. Okay, and when you open up this box, I'm just going to bring this down a little bit. I'm measuring 2 channels. Okay, the channel 0 thermistor, the thermistor on channel 0, and the voltage of the supply on channel 1. Now, if I want to change that label, I can do that by just putting supply voltage. It'll help you kind of remember what the function of that pin is. So I have supply voltage. And what's great about being in this DAC Assist is if I want to actually test that I'm getting the correct voltage, you can see my thermistor voltage and my supply voltage. Once you find that those are all okay, then you can close this. The other thing you might want to change is the range. My maximum should be 5, my minimum should be 0. Okay, and then once you've done all of that, you have to make sure you hit OK. Okay, and we know that it's working okay because when we do bring up the probe, so we can see those voltages as well. Okay, and I go up to View and Probe Watch window, and the thermistor is on the first channel. It was 2.54. Supplies on the second channel, 4.3. Yours might be reversed. Okay, and so you can specify which channel by actually clicking on this box here, and we want to select a single scalar. It's telling me that I'm channel 0, and the other one is going to be a single scalar on channel 1. Okay, I've changed it from the default of 0 to channel 1. And then I have a formula node, and the formula node is converting the resistance, or sorry, converting the supply voltage and the thermistor voltage to a resistance. And basically it's finding out the voltage across the thermistor and the current through the thermistor, and then calculating the resistance based on that. Afterwards, it leaves that, goes into scaling and mapping to do the linear interpolation, and then the filtering, and then it comes out here as filtered temperature in degrees Celsius. And then what I do next is I bring it into something called a bundle. Okay. And we're bringing in 4 signals so that it gets displayed on the waveform chart: filtered temperature, high temperature, low temperature. And I can also go to the chart on the front page. And on that chart, if I want to change the settings, I basically just click on the page. I can go to Properties, Display Format. I can change the time, the colors, the plots. So these are the different colors for temperature, temperature high, temperature low, and heat on and off, and even the thickness of the wires. Many things we can do in there. So back to the block diagram. So here's my program. I'm not showing you all the program, but coming into it is the set point, the deadband, the filtered temperature, and there is another input which is called heater out, because that's the one that needs to be latched, and the only way the latching will work is with this feedback node. Okay, and where do you get that feedback node? Well, let's just check that out. It's right here. Okay, so that's where you find the feedback node, and the 0 attached to the input, it's actually coming from the right. If you want to clean up that wire, you do that. It just makes it more obvious where it's coming from. This select function, what it does is gets the signal from heat on, and if it's true, it sends 22 out to the graph, which is the higher level, or else it sends 21, which is the lower level. It helps to indicate when the heater is on or off. Now, where did I get the select function? Right click, and I believe it's under comparisons. And let's see if we can find it here very quickly, right here. Okay, that's the select function. Okay, we'll close that window. The smoothing filter and the scaling and mapping, let's see if we can find those. So that's probably under Express VIs, signal analysis. I believe the filtering is right here. That's where you will find that one. And the scaling and mapping, let's see where we find that. The scaling and mapping, let's see. I just want to pause. All right, now I know where to find the scaling and mapping. You would right click, go to Express, Arithmetic and Comparisons, go to Scaling and Mapping, and that's actually where we have to define the table. So you go to Interpolation, click Define Table, and look up the table, which is placed on Brightspace. All right, so we've got a lot of these things here. Convert from dynamic data type. Where do you find that? That again is under measurement and I/O. And oh, sorry, it's in Express, signal manipulation, and this is where you'll find some of those different things from DTT to DDT. All right, anything else? The waveform chart, that you probably want to place on the front page. Where is this information going to? This is controlling the output. And in the lab, it may say to use 0, but I'm using bit 1. Okay, that's where I find it. So I went to not hide details, but to see details. And you can actually test it right here if you want. So you click on Run. This is a good way to test out your bulb. So to turn on the bulb, you click it. To turn off the bulb, you click it. So it's a low to actually turn off the bulb. Be aware of that in your software. That's why there's actually an inverter right here, because when heat on is true, we want the bulb to be off. Now let's look at a few front panel things that we can do. So we'll go up to Window, Show Front Panel. If I want to change the color of text on the screen, the way I would do that is I would highlight that box, okay, or I can just highlight this box. And you'll notice it has something called a marquee, which means that the box has this little ring going around it. And then I come up to Application Font, and we can go to Size, make it a little bit bigger. Okay, and then I can change the color. So up to here again, color, and let's say we want it in blue. Now we have it in blue. I can move it around. And let's make it bold as well. So up to Application Font and Style, Bold. And I think it's a little bit bolder there. So if you want to change the colors, that's a way to do it. The other thing that's important is when you are displaying numbers such as 31.4, you don't want it to be like 4 or 5 digits of precision. So to change it, you right click on that item, Display Format, and then you go to not data type, but make it floating point, 1 digit of precision. If you had 4, it would look like this. Okay, that's way too many. And you want to have 1, and we don't want to hide the trailing zeros, so we want to see them. So turn that off and select digits of precision. So again, it's floating point, 1 digit, digits of precision. Now, when you are working on this lab, make sure the graph is as large as you can make it. That's very helpful. The other thing that you can do is in this, when I run this program, notice it just went up 1/10 of a degree at a time. Okay, and I can change that. And one of the ways to do that is when you're on this slider, right click and go to Data Entry. And on this last little panel here where it says increment, you can choose how much you want it to go up or down by. And if it's not exactly what you want when you're moving this slider, you say coarse to the nearest. And it just brings the value to the nearest 1/10 of a degree. And OK to that. I think that's all I wanted to show you. So let's just see it running again. Oh, one more thing. On the graph, if I right click, and go to Properties and Plots and Scales. For the X-axis, don't have auto scale turned on. You can make the minimum 0, and the maximum that you can have is 1023, I believe. So I'm going to put 1023 there, select OK, and now when I run it, we don't have a 0, so let's try see if we can put a 0 at the beginning. To do that, you go back to Windows, Block Diagram, and actually on the front panel, no, sorry, Block Diagram, here's our waveform chart. You want to create a property node, and it's the property node called History Data. This must be outside the loop. That's really important. Change this to a right, and then click on this point here and say create and constant. And that should clear the screen. Okay. The other thing I wanted to point out here is depending on the data type that you want to use, if you want to change the data type, you right click on this and you go to representation. This is where you can change it to integer, single precision, double precision, whatever you might want to change it to. But for now, we'll just leave that there. I hopefully have covered everything that's important for Lab 4.